Okay, Assalamualaikum and hello everyone. So kita akan sambung dengan 8.4 in physical optic. So before we continue with 8.4, kita recap sikit apa yang kita dah belajar in 8.1. Okay, in 8.1 we have learned about interference. So there are two syarat untuk interference berlaku. The first one ialah we must have two coherent sources. What is mean by coherent sources? The first one, it must have same lambda and same frequency, and the second one, it must have a constant phase difference. Okay, so ini ialah coherent source, dan two coherent source and amplitude of the wave are equal ialah syarat untuk interference terjadi. Okay, so in interference we have two case. The first one dia ialah in phase. So what is mean by in phase? Pada permulaan, sebab kita ada dua coherent source, pada permulaan dua-dua wave kita is either positive A ataupun both negative A. Dan dalam in phase ada dua. The first one, dia akan menghasilkan konstruktif, ataupun nama lain bagi konstruktif ialah bright fringes. Okay, so kalau konstruktif ataupun bright fringes, dia punya path difference ialah m lambda. Kalau dia menghasilkan destruktif ataupun dark fringes, dia ialah delta L m plus half lambda. Okay, and case yang kedua ialah antiphase. What is mean by antiphase? Dua coherent source saya, satu positif A dan satu negatif A at the beginning. Okay, dan pengakhiran dia untuk menghasilkan bright fringes, kalau dia antiphase, the path difference must delta L m plus half lambda. Kalau destruktif, delta L equals to m lambda. Okay, ini untuk 8.1 and 8.2. And in 8.3, we have learned about yang double slit. Okay, so untuk yang double slit, dia always in phase. Why it is always in phase? Sebab it is always from the same source. So kalau same source, obviously dia akan mempunyai in phase yang sama. Maksudnya source yang pertama positif A, source yang kedua juga akan jadi positif A. Okay, for in phase, in yang double slit, for the constructive interference, Ym equals to m lambda d over d, and for destructive, Ym equals to m plus half lambda d over d. And m is the number of order, and kita ada Ym, and Ym is always from the central bright of the interference pattern. Okay, and the second one, we have two consecutive interference. Dia ialah two consecutive berturutan, is either bright fringes ataupun dark fringes yang bersebelahan. Okay, so the equation akan jadi delta Y equals to lambda d over d, and we have learned how to find the number of order. Okay, alright. So today kita akan masuk 8.4, interference of reflected light in thin film. Okay, so what is thin film? Okay, for example, in our daily life, the most related to us, thin film ialah kita punya screen protector on our phone. So what is thin film? So thin film ialah, okay, thin film dia ialah lapisan yang nipis yang boleh menjadi protection for our screen. Okay, so the first one ialah learning objective yang pertama, to identify the occurrence of phase change upon reflection. 8.4b, describe with the aid of diagram the interference of light in thin film at normal incident. Learning 8.4c and D, use the following equation for reflected light with no phase difference and with phase difference. And 8.4, explain the application of thin film. Okay, so kita tahu, kita dah belajar tadi 8.1 and 8.2. Kita belajar ada dua source, is either in phase ataupun anti phase. Okay, kalau in phase, kalau dia menghasilkan konstruktif ataupun bright fringes, the path difference akan jadi m lambda. Kalau dia menghasilkan destruktif ataupun dark fringes, delta L equals to m plus half lambda. Okay. Kalau antiphase, dia menghasilkan constructive ataupun bright fringes, delta L equals to M plus half lambda. Kalau dia menghasilkan dark fringes, delta L equals to M lambda. Okay. And we know for double slit, it always in phase. Double slit dia in phase. Tetapi in thin film, okay, so thin film dia kata reflected light with no phase difference. Okay. Macam mana kita nak tahu adakah dia in phase ataupun dia anti phase? Okay. So figure shows a thin transparent film of reflective index N and thickness Tm on a medium of refractive index N2. Okay. So figure ini tunjukkan ada satu lapisan nipis which is N, thicknessnya ialah Tm, yang berada di atas permukaan 3.5. Okay, so this is the thin film, this is the surface, and ini ialah air. Okay, a ray in medium N1 is incident at almost normal incident. The ray is partly reflected at the top surface of the film. The angle of incident theta is, the figure is very small, almost zero, but has been enlarged for the purpose of clarity. Okay, so kita tahu ada satu cahaya yang masuk melalui air. Okay, separuh dia akan terpantul, separuh dia akan terbias. So, dia kata dekat sini, N1 is smaller than N2. No, N1 is smaller than N. The reflected ray 1 experience a phase change of 5 radian. Kenapa? Okay, kalau kamu tengok kat sini, N1 ni nilai dia 1. N ialah 1.5. 1 lagi kecil daripada 1.5. So, bila dia terpantul, dia akan ada phase difference sebanyak pi radian. Okay, so kalau saya starkan dekat sini, from less dense to denser, dia akan ada phase difference sebanyak pi radian. Okay, so dia terpantul sebanyak pi radian. Ini daripada less dense to denser. Okay, so separuh terpantul dan separuh terbias. So yang ini yang terbias, dia akan masuk melalui N dan pergi ke N2. So kalau kamu tengok, N is smaller than N2. So, ray 2 also experience a phase change of pi radian. So, sebab dia kurang, 1.5 kurang daripada 3.5, so dia juga akan ada phase change sebanyak pi radian. Okay, so pi dan pi, ray 1 and ray 2, dia ialah in phase. The delta L is equals to 2T. Disebabkan daripada less dense to denser ada pi radian, less dense to denser ada pi radian, makanya mereka ada pi radian phase change, dan untuk ini dia ialah no phase difference ataupun we call as in phase. Okay, so how we want to know dia ialah in phase ke anti phase? Kamu tengok number of N dia berturutan 1, 1.5, 3.5. So dia semakin meningkat. Okay, so itu ialah in phase. So you have to know how to draw this ray diagram. Okay, now we go to the second one, reflected light of phase difference pi radian. Okay, for example, kamu tengok dekat sini. Yang pertama, daripada N1 pergi ke N. 1 pergi 1.33. Dia tulis kat sini, N is smaller than N. So, the reflected ray 1 experience a phase change of pi radian. Okay, sebab less dense to denser, dia akan ada phase difference sebanyak pi radian. Okay, tetapi N pergi dekat N1, another N1 which is 1.33 pergi dekat 1. Denser to less dense. Okay, kalau saya tulis kat sini, okay, denser to less dense akan ada phase difference sebanyak 0. Makanya dia tak akan ada phase difference. Okay, sebab 1.33 ni lagi besar daripada 1. So dia tak ada phase change. Disebabkan mereka tiada phase change, ray 1 and ray 2 are anti-phase. Okay, so here also the thin film. Dan mereka ialah anti-phase. Sebabkan mereka anti-phase, macam mana tahu dia anti-phase? Kamu tengok number of N tidak berturutan. So kalau macam tadi, number of N dia 1, 1.5, 3.5. But this one, 1, 1.33, dia akan pergi 1 balik. So dia tak berturutan. So kalau dia tak berturutan, dia always anti-phase. Okay, this is how we want to identify is either kita punya light are in phase or anti-phase. Okay. Okay, so it's for the explanation. And for the equation, if the light is in phase and dia constructive, okay, macam yang saya tulis kat sini tadi, sekejap copy. Okay. So dia boleh jadi okay. Kalau dia in phase dan dia konstruktif, dia akan jadi delta LM lambda. So kalau kita nak kat nota kita, kalau dia in phase dan dia constructive interference, 2 NT equals to M lambda. Kalau dia destructive dan dia in phase, so dia ialah M plus half lambda. Kenapa? Sebab yang kita tadi, kalau dia destructive, dia kena ada plus half lambda. Okay. Manakala kalau dia anti-phase dan dia konstruktif, so 2 NT equals to M plus half lambda, tetapi kalau dia destructive, 2 NT equals to M lambda. So what is 2? 2 is the number, N. N is the refractive index of the thin film. Yang mana thin film punya? Thin film always berada di tengah antara dua medium. Okay, so N this one, nilai thin film, dan T is the thickness of the thin film. So where is the thickness of this film? Thin film is this one, and M is the number of order, lambda is the wavelength. Okay, alright. So that's the explanation for the thin film. Okay, so we have the summary here. Okay, so this is our thin film summary. We know that thin film boleh jadi dua keadaan. The first one ialah in phase, the second one is anti-phase. How we want to identify in phase or anti-phase in the question paper? Okay, the first one, kalau soalan mention no phase difference. Kalau no phase difference, automatic dia in phase. Okay, so kata kunci lain nak pastikan dia in phase. Kalau soalan mention anti-reflective coating, or you tengok number of N dia berturutan, maksudnya 1, 1.2, 1.55, so they are berturutan. Kalau mereka berturutan, dia ialah in phase. Dan kalau soalan mention blooming of lenses, okay, so kalau in phase dan dia konstruktif, the equation akan jadi 2 NT equals to M lambda. Kalau dia destruktif, 2 NT equals to M plus half lambda. Okay, how we want to identify kalau dia anti-phase? So kalau anti-phase, the question said that there is the phase difference. There is the phase difference. It is anti-phase. And kalau soalan mention reflective coating. Kalau in phase dia anti-reflective coating. Kalau anti-phase dia reflective coating, then you boleh tengok N dia tidak berturutan. So this one 1.3 and 1. Okay. Or another, the soalan mention bubble or thin soap. Why bubble or thin soap is anti-phase? Because air dekat luar, the bubble is the thin film, dekat dalam bubble ada lagi air. So dia ialah 1.0, 1.33 for example, and 1.0 back. So they are anti-phase. Okay. For anti-phase constructive, 2 NT equals to M plus half lambda. For destructive, 2 NT equals to M lambda. Okay. But if the question asks the minimum thickness or minimum wavelength, no, biasanya minimum thickness, kita hanya akan ambil nilai M kita sebagai, kalau M lambda dia kena jadi 1. Kalau M plus half lambda, M equals to 0. Sebab dia nak minimum kan. Kalau this one, M mesti jadi kosong sebab we still have 1/2. Okay. Kalau M lambda tak boleh kosong sebab dia akan jadi kosong. So, M ni akan jadi 1. Okay. So, that's how we use this equation. Alright. We go to the next one. Explain the application of thin film. So, thin film in our daily life. The application of thin film. Okay. So, thin film do play an important role in many branches of material science and engineering. So, the application of thin film, the first one, thin film solar panel. So, solar panel yang untuk collect all the solar energy. Okay. The second one, anti-reflection coating on lenses, glasses or solar cell. So, kalau kamu tengok anti-reflection coating, dia ialah yang berada dekat spek mata, yang kalau you jalan dekat bawah matahari, tiba-tiba you punya spek mata tiba-tiba jadi gelap. So that's because of the thin film. Maksudnya you letak one lapisan of film dekat atas you punya spek mata, menyebabkan bila cahaya hit you punya spectacles, dia akan terpantul balik. So menyebabkan dia menjadi gelap lah. So it's anti-reflective coating on glasses, cut glares and allow more light through to your eyes. It allows more light to pass through your lenses to your eyes, giving you a sharper and clearer vision. Okay. Satu lagi yang you tampal dekat kereta atau dekat cermin tingkap rumah. Okay. And the third one, reflection coating for mirrors. Ni yang kita tampal dekat tingkap kita, yang macam kalau siang dalam boleh nampak luar, kalau malam luar yang boleh nampak dalam. So sebab ada thin film. Okay. 4 coating produce decoration, colours and luster, and the 5th one CDs, DVDs and upcoming days. Sebab tu kita nampak dekat CDs, kalau you kenal CD lagi lah, dia ada berkilat. Dan kalau tercalar, all the data dah tak boleh baca sangat. Okay, okay, so that's for the explanation. And kita